Okay, hello everyone. Myself Sachin Kumar, working as a professor at Computer Science and Engineering Department of AKGEC Engineering College, Ghaziabad. We are going to discuss a topic, address calculation of row measure and column measure if array is given. First of all, we need to understand what is the array and how we can represent the array. For example, I've taken here, this is the 2D representation of the array. We have here two-dimensional array. For example, first element is represented is here A00. A00 means here row is 0, column is 0. So next one is here A01, row is 0, column is 1. And A02, row is 0, column is 2. So in this way, people are able to represent the array. For example, the address of A00 is 1000, and we are assuming that every element takes 2 bytes. Then the address of the next location will be here 1002, because array takes the contiguous memory. If first one is taking the 1000 location, then second one will take 1002 location, and similarly next one will take 1004. And when we talk about the next array, next row, then in that case this address would be here 1006. So in this way, people can find out the address of any location. I mean, we have here systematic arrangement. So if you people have the starting address, and starting address is also called the base address, then you can find out the address of the any memory location, because address is allocated contiguously. We have the some relation, some formula. Based on that, we can find out the address of any memory location if you have the base address, because memory is being allocated contiguously. Okay, now array has basically two kinds of the representation. First one is called the row measure, and second one is called the column measure. We have the different formulas for the row measure arrangement as well as the column measure arrangement. So first of all, we need to understand how we are representing the row measure representation and column measure representation. After that, we can easily drive the formula, and to drive the formula, this is the very simple job. And using this this particular lecture, you people are able to drive the formula for any dimension. This is a very easy technique. So I recommend you kindly watch this video up to end, so that you can easily drive the formula for any location, or for any kind of the array. I mean, it may be 2D array or 3D array or 4D array, or it may be ND array. Coming back to our topic, row measure order. So here array is represented in form the rows. I mean, this is the row, first row, then next row, then next row. So this is the row measure representation. If you are working row wise, row measure, and if you are working column wise, then column measure representation. In the row measure representation, further say we are assuming that every location takes 2 bytes memory. Then suppose first one is taking 1000 memory location, then next one take 1002 and 1004, like that, 1006. So in this way, the people are able to represent the row measure representation. And when we talk about the column measure representation, then we people are able to write these addresses like this. Suppose first one is taking the 1000 location, then next one take 1002, 1004. So in this way, addresses are written. So this is the very easy approach to understand how addresses are representing in the row measure as well as the column measure. After that, now we people are trying to write out the formula of address calculation for the 2D array. So first of all, I am trying to explore the formula, how we can write the formula for the 2D array. So this is a very easy technique to write the formula here. The formula, first of all, I am writing the formula for the row measure. How we can write the formula for the row measure? So we are using here, various terminology here, and these terminologies are here: base address plus size, and this size is multiplied by E1 L2 plus E2. So this is the way to write the formula of row measure. So what are the E's and these L? We need to try to understand these E's and L so that we can understand the formula in the very easy way. Base address is the starting address, as we have mentioned that very first address of the array is the base address. So in the previous example, base address was the 1000. So we can write the base address equals to 1000 as per the previous conventions, previous example. And if we are taking the size of the integer, it may take suppose 2 bytes. So integer normally takes 2 bytes, or float takes normally 4 bytes. So if we are using the integer, then size would be here 2. Then size is replaced by here 2. And what are the E's and L? Basically, E is here effective address and L is here length. E stands for here effective address, and L stands for here length. What is the length of particular dimension? So we are representing using the L, and through E effective address. And now, for example, if we have the column measure representation, then our formula would be base address plus size, and we need to start with E2, and in the row measure we need to start with the E1, E2 L1 plus E1. And important point is here, the difference between in each E and L is 1. In row measure we are starting with the E1, then L should be L2, because the difference between E and L is 1, and E1 L2 plus E2. Similarly, in the column measure we are starting with the E2. What are the E2s? I will clear with the help of the example, but at this point you may just remember we need to start with the E2 if we are using the column measure. So E2 L2, E2 L1 plus E1, because difference between E and L is 1, therefore E2 L1. So in this way you can easily remember the formula of row measure and column measure. Now I am mentioning here example how we can, using this formula, if any example is given, how we can find out the address of any memory location using the row measure or column measure if two-dimensional array is given. So I am writing here few entries, just like my array is given integer, array is given here integer A, minus 10, 20 and 10, 30. So it means row is starting from minus 10 and going up to 20. Column is starting with 10 and going up to 30. So L1 and L2 we can easily derive. So L1 is basically here for the first bracket, I mean dimension 1, and L2 for the dimension 2. So L1 would be here length. For the length, what we need to do here, we need to write here upper address, lower address plus 1. So therefore, L1 will be here 20 minus 10. So we need to subtract minus 10, I mean upper address minus lower address plus 1. So in this way, 20 plus 10, 30 plus 1, 31. So 31 is the L1. So in this way, B people are able to get the L1. And what is the L2 now? L2 will be here for the second dimension. So starting point is here 10 and last point is here 30. So therefore, upper point 30 minus lower point 10 plus 1. So therefore, 30 minus 10 plus 1. So it should be here 21. So we people are able to easily find out the value of the L1 and L2, and these L1 and L2 we have mentioned in the previous formula. Now we need to get the E1 and E2. For example, here you want to find out the address of, for example, you want to find out the address of A5, 8. What is the address of the A5 and 8? So E1 and E2 depends upon the location for which you are going to find out the address. So E1 is here, E1 for the dimension 1, effective address is here E1. So E1 will be here 5 and minus starting address E1 5 minus 10. 10 already is minus. Then effective address will be here 5 plus 10, it would be 15. Now E2 will be here effective address, I mean this is here 30 and this one is here 8. So effective difference will be here 30 minus 8. 30 minus 8. Because we want to find out the address of the this is not 30 minus 8, correct it. Basically you are at the 10th location, and actually you may replace not 8 here, you may replace it by the 18, because column size should be in between 10 to 30 and it is not correct here. So replace 8 by 18. So if you want to find out the address of the 18, then the starting point is 10 and required column is the 18. So therefore E2 will be here, starting point is 10, this one is here 18, then 18 minus 10, it will be here 8. So we people are able to find out the E1 and E2. Now everything is well defined. We have the E1, we have E2, we have here L1, we have here L2. Now we need to place these values, and after placing these values we can easily compute the address of the any memory allocation. Further, I am writing one more example for the better clarity. Now say array is given integer a starting from -6 going up to 10 and column starting from -4 going up to 20, and we need to find out the address of A, say 1, first row, and column is here 13. So we need to find out the address of 1 and 13 location. So further here we need to find out the E and L first. After getting the value of E and L, we can easily find out the address of the any memory location. So for example, this one is here, E1 would be here. First of all, find out the L1. So L1 means here upper bound minus lower bound plus 1. So therefore 10 plus 6 plus 1, 17. Now L2 would be here upper bound minus lower bound plus 1. So 20 minus 10 plus 1, this is here L2. So L1, LL2, we people have easily find out that. After it, we need to find out the E1 and E2. E1 will be here effective address. Effective address is here, say you are here at the -6 and you need to go to 1. So therefore 1 plus 6 equals to 7, and E2 would be here. You are at 10 and need to go to the 13. So therefore 13 minus 10, it would be here 3. So effective address in this case is here 3. Now we people are trying to find out the address of the 3D location, how we can find out the address for the 3 dimension. So basically further here, first of all we need to write the formula, and the way is here once again very simple to write the formula for the 3-dimensional array. The method is further here very simple. Base address plus E1 L2, it should be multiplied by the size plus E2, then whole should be multiplied by L3 plus E3, like this. So in this way we can find out the formula for the row measure representation, row measure. So further here important point is here to note down the observation, and our observation is here, further difference is 1. I mean E1 L2 plus E2 whole is multiplied by L3 plus E3. Now for the column measure, base address plus size, and we need to start with the E3 if we are dealing with the column measure. E3 L2 plus E2 L1 plus E1. So in this way we people are able to find out the address for the 3D location, 3D array. I mean in generalized you can write down the formula for any dimensional array, and important point is that here in the row measure always start with the E1, in the column measure start with the highest value of E, and the difference between E and L is 1. So you people can easily write down the formula for the row measure and column measure by remembering here this particular practice. Now for example, say example is given, and how you can find out the address for the any location of the three-dimensional array. Further here, say base address is here 1000 and array is given integer a 10, 20 and 30, and you are finding out the address of A 5 6 4. Then for the row measure or column measure, terminologies, to get the value of En and L will be same, but formula is different. So first of all, you need to find out the value of E1, E2, E3 or L1, L2 and L3. Very simple. L1 is here, length for the dimension 1, starting from 0 and going up to 9. So L1 is here 10, length is here 10. L2 is here, starting from 0 going up to 19. So L2 is here 20. Similarly, L3 is here 30. After getting the L1, L2 and L3, we need to find out the value of E1, E2 and E3. So what are these? E1 is here effective address. Basically here we need to find out for the A5, and we are starting from the 0. If nothing is given and we are using the C programming procedure, C programming conventions, then starting address is the 0. If starting address is not given, we are assuming that starting address is the 0. Then starting address is 0, then we can find out the E1, E2 and E3. E1 is here effective address for the dimension 1, 5, and starting address is a 0, 5 minus 0. This is here 5. E2 is here. E2 is here 6 minus 0. This is 6. E3 is here 4 minus 0. This is 4. So people are able to find out the value of E1, E2 and E3, L1, L2 and L3. So after putting these values in our formula, we can find out the address of the any memory location. And in the last, I am also going to write the formula for the 4D array, so that there should be no doubt how we can derive the formula. So this is very simple here. Say I am going to write here formula for the 4D array. So first of all, row measure. Terminologies are here very simple. Base address plus size, E1, L2 plus E2, this is multiplied by L3. Now E3 E1 L2 plus E2 multiplied by L3, and now E4, this is multiplied by whole L4, and in the last we are writing here for E4. So further it, E1 L2 plus E2 whole is multiplied by E3 plus E3 whole is multiplied by E4 plus E4. This is the representation for the row measure, and similarly you can also write the formula for the column measure. So terminologies are here very simple, and you people, I'm sure that you people can find out the address of the any memory location, and you can easily read out the formula, you can easily derive out the formula. So thank you very much for your patience.